This question is related to fluid dynamics or a fluid flow. Rain consists of droplets of water of different size. Explain why larger droplets of a rain reach the ground more quickly. Assume that the upthrust acting on the raindrop is negligible. So, like example, we have two types of different size of droplets are there, but if we are taking two. So, why this large one reach the ground quickly as compared to the small one? And remember, upthrust, as I mentioned, the upthrust, upward force is there, that is upthrust, and the viscous drag always try to oppose the motion. But we can say the viscous drag, the upthrust is negligible as they mentioned here, because the upthrust depends on density of a fluid, volume of object, and gravity. Because volume of object is very small, the raindrop size is very small. That's why we consider that negligible upthrust is there. So the small one, well, example, the large raindrop, they will have a higher terminal velocity, but small raindrops will have a lower terminal velocity. And when they reach a terminal velocity, that moment, the weight which is acting downward will be equal to upthrust or, sorry, drag, we can also say, because upthrust is negligible. So see, the large drops have higher terminal velocity compared to small drops. That is one thing. So when they reach the terminal velocity, when they reach the terminal velocity, what will happen? That time I can say the weight is equals to the drag force or viscous drag. And what about when we compare them, weight is equals to mg. So I can say mg is equals to the viscous drag or a drag force for a spherical object according to Stokes' law, that is 6 pi eta r and v. What about mass of an object? Mass is density into volume, density of object multiplied by volume. And what about volume of a sphere? The volume of a sphere is 4 by 3 pi r cube. So I can say volume here will be equal to 4 by 3 pi r cube. So in place of mass, I can write density into volume. And after writing density into volume, I can write 4 by 3 pi r cube is equals to 6 pi eta r and v. When I simplify this, r will cancel with one of the, like the r, the one is r, another one is r cube. So they cancel out. Rest all are constant. So what is the relation between terminal velocity and the size? They are proportional with square. So means if the size is double, then the terminal velocity will be 4 times. It will have a higher terminal velocity. And when it is having a higher terminal velocity, as a result, what will happen? It will move faster. And when it will move faster, it will cover the same distance in a short time. And large raindrop has to reach a higher velocity to reach the terminal velocity.